American Space Museum. I'm Marquette, and we're so glad you're with us to stay curious. Today we're with Terry White, Orbital Processing Facility Manager, and a great friend of the museum. And a lot of people know Terry in the shuttle era. They just say that guy with the mustache. How you doing, Terry, my friend?
I'm doing good today.
Well, we're glad to have you back. We missed you in the month of October because you were undergoing a little medical procedure there, and hope you're doing fine.
Yeah, everything seems to be working well.
Well, good. So your friends out there that know you had something done, everything's nominal, and you're just correcting along the line there. Well, that's good. Our program today, we're going to talk about getting this bird, Columbia, behind us here on its first landing back in space again, which was a monumental concept as well as a monumental feat to be achieved. And you were one of the spokes in the wheel of the whole machinery there, Terry.
Yeah, this was the challenge of what the vehicle was designed for. It was designed to go to space, come back, and refurbish it and send it back to space again. So STS-2, that was our challenge, to take this vehicle, inspect it, repair it, change out the payload, get the next crew, get everything processed, and get the crew trained for this specific mission, and put Columbia back up to space again.
And that's what we're going to talk about here on Stay Curious, and we hope all of our regular watchers are out there. Watch us on YouTube. We make a nickel a show. We're up to 584 episodes today.
Good.
All right, so we made about $3. No, not really, but it does help our museum, and the magic numbers of the social media is what the world revolves around, and the American Space Museum's happy to be involved in that. For 21 years, we've been preserving the birth of America's space age right here in its delivery room. We call it Brevard County. We're going to talk about two events going on before we get into Terry real quick, but we want to thank the Holiday Inn in Titusville at Exit 95. We are broadcasting from the Holiday Inn studios today as they are sponsoring Stay Curious and helping us out with our inaugural memorabilia show, which is this Saturday at the Holiday Inn. We hope to raise $5,000 for gallery upgrades. Thank you to Delaware North, Bid Again Auctions, and Ken Havicott's Memorabilia for sponsoring our show. If you want to know how much something is appraised at, like a shuttle tile you may own, we will have Chuck Jeffrey and Ken Havicott appraising items for free. We will ask for a donation to support our nonprofit, and of course we still have some tables available, so call us and we'll get you set up for that. But today we're going to have the Shuttle Garage with Terry White, Orbital Processing Chief. Terry, there's the beautiful bird late in, I think that's Endeavor in the 2000s, but an interesting shot to show you all the platforms in this building. That here's your home, here's your office, Terry. Marty, point out the OPFs there. There's two on the right and one on the left. And we've been driving around those, Marty and myself and some of our friends here. We've been taking the tours out of Kennedy Space Center. We've gone out to the Saturn V Center a couple of times. There's OPF. Is that one?
That's one. And for STS-2, OPF-1 was the only operational bay. 2 was coming online, and 3 hadn't even been envisioned yet.
In 1981 is the first launch of Columbia, April 12th. That last one is where the that's where the Boeing Starliner is.
Is in
in 3, and they have the X-37B top secret mini shuttle.
It's in OPF-1.
In OPF-1 there. And have you ever snuck in there to look at it?
No, they won't let me in there anymore.
They won't let you in. Not even with your passes that you say.
Nope.
No, that's a shame. But keeping our country safe, you better believe, happening there. Some good top secrets, and of course behind there is the gigantic vehicle assembly building, our iconic structure here on the Space Coast. Another picture of the facility there, as you all see it there, the back left are the OPFs. But Marty, point out, and as Terry comments there, where the shuttle runway is and how these shuttles are brought back.
Yeah, that portion that he's at right now, that is the shuttle landing facility. That's where an orbiter returning from space would land. If it had landed at Edwards Air Force Base, then that's what it would ferry back on the 747 to the same runway. Then we would tow the orbiter down the towway, down State Road 3, and make the turn into the towway in front of OPF 1 and 2, and take it into whichever hangar it was going. And for STS-2, it was going into OPF number 1.
And there is the distinctive doors to the hangars.
Yes.
Distinctive because...
Yeah, well, that has the cutout to fit the tail.
Yeah.
But yeah, it is, that is Columbia coming into OPF 1, and it's being taken in by a tug, towed in, and we spot it. It has to be in exact position so all the platforms fit around it and that. Now, once we get it in, then we actually have to take it up to what we call maintenance height, where we jack the orbiter up off of the ground so we can do hydraulic operations to raise and lower the gear and test them. But everything is a precise fit in there. We try and close up all the gaps around the orbiter to less than 12 inches. A lot of them are down to the 6-inch time frame.
Wow, and Terry, you have a little trick that our Stay Curious people will love to know to how to quickly determine that is orbiter 102
Yes.
tail number.
Yeah, if you look at the orbiters, Columbia is the only one that has black on the leading edge of the wing on the upper surface. Because shortly before STS-1 rollout from the orbiter processing facility, the engineering community thought that the temperature differential on re-entry, with the lower wing getting so hot and the upper wing being so cool from the temperatures of space, that there might be some issues simply because of the temperature range. So they tasked us to paint that thin portion of the wing black so that they could, Crippen and Young could roll it toward the sun and heat that portion up before they re-entered. So Columbia was the only one. We realized that it wasn't necessary, but it was the only one that ever had the black on the upper wing, and we maintained it until STS-107.
Interesting. Well, Terry, you have been a spokesman for NASA in various capacities, and we wanted to just by saying thank you for your service, show one of the awards that you were given by the National Space Club in 2014, their Hall of Fame Award. And I know you're a little shy to talk about these type of things, but we want our Stay Curious people to know that you're well thought of out there. This is one of the shuttle's people that I always hear about, that always good things said about you and your management style and so forth, Terry. But I know you always give your team credit.
Correct. And here we are at the runway, and with two of the techs that have worked with me for many years. The one on my right, Jimmy Carter, he worked STS-1 all the way through to STS-135, and Charlie Romeo started out in the mid-'80s and came to work for me, and the two great individuals, and they're still working out at the Space Center today.
And it is truly a family, folks, as I've been involved and been around this inner circle of shuttle people now for over 5 years. And people like Marty Winkle, I haven't given a shout out to the Launch Process Service in SSME manager Marty, our co-producer here today. And it's such a family, Terry. I mean, and you all have stayed in touch, it seems like, a lot of you.
Yes, we have. Yeah.
In the 11 years since the last shuttle landed.
Well, I tell people, because especially in the earlier days, we spent more time working out at the Space Center than we did with our own families. Mm-hmm. I mean, STS-2, most of that entire flow was 12 hours a day, 7 days a week.
Mm-hmm. Well, as we look at the landing of STS-1 on April 14th, 1921, I want to just mention two items of history going on today. One, Jeff Hoffman, an astronaut that flew 5 times in a shuttle, it's his birthday today, born in Brooklyn, New York. He's 78. And I can't go without talking about a moment and reflecting that 22 years ago today, American astronaut Bill Shepard was the commander of Expedition 1 that docked with the Neophyte space station, which was like 2 long tubes together. And Bill Shepard and 2 Russians took residency in the International Space Station on November 2nd, the year 2000, and 22 years later, Terry,
It's still
there's
occupied.
there's not a person who's 21 years old or 22 years old walking on the face of the earth that can't say there was somebody living in outer space
Correct.
during their lifetime. How does that make you feel, being part of the shuttle program that achieved this for humanity?
Really proud of the fact that it brought so many countries together to develop it, and that the U.S. launched the majority of the hardware up there to construct the International Space Station. And like you said, that it's still operating today, 22 years later. And we have a diverse crew of astronauts from multiple countries. We now have 40 countries have astronauts.
Wow, that's amazing. And as we're being a little patriotic here, why don't you give your son a shout out? Your son,
He's
name?
Travis White. He's a major in the U.S. Army, and the last time he watched this show, he was in Iraq, but he is home now, and he's currently out in the West.
So thank you for your service to our country, young man, and you've got some other military friends watching you today, keing you straight, right, Terry?
Correct.
They're
Military
keeping me
friends
straight mostly. I'm the one that'll get the
and
grief.
family watching it. They will critique me at the end of the show.
Well, we appreciate you. And it's so valuable that we have friends like this that want to participate on Stay Curious. And it's wonderful for you out there to enjoy their stories. After all, they lived it, and now they're sharing it with us. And this is the future of the American Space Museum, is our shuttle era people. They're young. I'm sorry, the Apollo guys, Marty's one of the youngest of the Apollo guys, but most of them are in their 80s to late 80s. And, their story's been told half a century later. And it's important that we get your story out, Terry, and the beautiful people of the shuttle era there. Marty, you have a question?
Yeah, I have to go back a couple of pictures, though.
Okay.
Question comes, maybe. I think it's this picture. Brian Anderson, the picture on the left. I think it's this picture. Okay. What is the vehicle behind the shuttle?
Okay, the vehicle behind the shuttle.
Oh, he's talking about the green screen.
Yeah. Okay.
Oh, the green screen's behind it there. Yeah. Okay. Yeah, you
Okay.
got the green screen behind it. All right.
Yeah. As soon as the orbiter lands, we send people in special suits out to go around and sample around the orbiter to make sure there's nothing hazardous leaking that would prevent us from getting the orbiter hooked up and taken to the orbiter processing facility. Well, one of the things we have to do is we have to supply it with air conditioning. Most of the time it is very hot in here, but the astronauts in there need conditioned air to continue to breathe. They're still safing the systems from the inside. So the thing on the left-hand side of the picture, the three red hoses, that's one hose is providing conditioned air to the aft compartment of the vehicle, another one to the mid-body, and the other one to the crew module. And we have to maintain certain temperatures with the orbiter, especially if we have live payloads in there. We have to maintain all that. So, and then we hook up other things on the right-hand side. We hook up other things to supply power and that to the orbiter, and then once everything is safe and we've got the crew out and they got a chance to do a walk around the orbiter and we've hooked up the tug and everything's ready, then we tow the orbiter back to the orbiter processing facilities. And some people say, well, it's not the best walk, but everybody I know that gets to walk the orbiter back is very proud that they get to walk this spacecraft back to the hangar.
So you're walking it back all the way from the runway that Marty showed us.
All the way back to the orbiter processing facility.
So you're only going about a mile an hour, if that.
It depends who the tug driver is. Some of them will get a little bit of a lead foot.
Oh, really? Will they? Well, there is the tug going on there. And thank you for your question there. We'll show you a little more in depth there. So we've had Travis Thompson, the lead closeout crew, friend of our museum, talk about being there. Other sections, I'm sure, are there of the responsibility for all this orbiter.
Correct.
Who's the one calling all the shots?
Well, we have a similar to the launch director, but we have someone who is in charge of the landing operation. They're in a camper type vehicle. It's set up as a command center, but it stays out there at the runway with it, the landing, and then they go with it
Okay.
all the way back in, and they control and give the blessing for everything going
So
on
you
there.
got to have a leader on that. And one of Triple T's famous stories is when the tow truck got ahead of the orbiter and pulled out uh, some of the hoses.
Yeah.
Yeah, you remember that one?
No,
I'm
I
sure.
do not remember
Oh,
that
you don't
one,
remember
no.
that one? Oh, okay.
Nope.
Yeah, you guys have to get together
Yeah,
on that.
somebody wasn't sharp on the radios. Though.
Yeah, no, they weren't. They
No,
weren't, and
yeah.
and they had a radio glitch or something
Yeah.
that had happened. On
And
it.
because
So yeah,
and
so that's how you communicate is walkie-talkie radios.
Yep.
Huh?
And because the orbiter is still powered up, when we get the astronauts out, or when the astronauts come out, we have to put 2 spacecraft operators inside. They are 2 technicians that know all the operation of the vehicle, and they go into the pilot and commander's seat, and they operate, and they get closed up inside. And then when we get to the outside of the OPF, we take those 2 members out and put 2 others in, and then they're closed in, and we can't get to them, and they can't get out until we get it inside the hangar and bring it up to its maintenance height that I talked about before, so we can safely open the hatch again and get them out.
So from landing to this stage here is how long a time frame, Terry?
From a normal landing, something like this would be in the neighborhood of probably about 6-7 hours.
Wow, a full day for everybody, right?
Yeah.
So
Yeah, it's a lot longer when it ferries back on the 747.
of course, and because they have to go to the mate demate.
Yes.
We didn't throw a picture in that, but my question is, any different with the night landings?
Well, the night landings are the most impressive because there's no lights on the orbiter, and they're not shining any lights up at the orbiter. You don't want to.
While you're walking it back to the
Yeah,
OPF.
but even when you're walking back, but you're standing at the runway, you've heard the sonic booms, and you know it's close, and then all of a sudden it comes streaking by you in the dark. You know, and just 100 feet away from you in the dark, and then it lands, and then walking it back. Usually a night landing, by the time you get ready to come back, it's already daylight.
Yeah.
Yeah. Otherwise, you just have to look out for the rattlesnakes and the alligators.
I was going to say, you got anyone walking around with the rifles? I mean, seriously, along
We
the
have
way
security, but most of the critters out at the Space Center have a fear of people, so they will get out of your way.
Very interesting. We're enjoying Terry White, Space Shuttle Manager, through the whole shebang, the 3 decades of our fabulous orbiters, one of the greatest assets America's ever built, in my opinion, and the result of it is the International Space Station that we mentioned. We're celebrating today 22 years that it's been continuously occupied by human beings. I've not seen anybody do a total of the number of people lived up there. I'll have to look into that for tomorrow's show. But we're going to have Terry, excuse me, share a little bit about, as we look at more of those hoses and stuff going in there, about getting this bird down on the ground and ready to launch again for STS-2, which this was designed to do, a reusable spacecraft. But I'm here to tell you, that second flight has to be just as scary as the first, in my opinion.
Well, we learned a lot of things from the first flight, and prior to the first flight, we'd had an issue with the tiles. I have one of them right here, but the tiles were not adhering to the ship prior to STS-1. So we had to take the tiles off of the ship, harden the back of them, and reinstall them. Well, Columbia had over 32,000 tiles on it, and they opted to go launch STS-1 before we removed, hardened, and replaced all of the tiles. Now, we'd done all of the tiles on the lower surface and all the black area you see here, and all the critical tiles on the upper surface, but we did not get all of them removed and hardened. So when we flew STS-1, we lost tiles in the lower temperature areas. We lost some forward of the windows, above the crew module, back on the OMS pods. The OMS pod was the only ones that the astronauts in flight could see that some tile were missing in that. But it didn't cause any overtemp of the structure of the vehicle, but then we had to replace all of those tiles, and we also had to replace a lot of tiles that were damaged on the ship.
OMS is an acronym.
Oh, yeah, the OMS is the Orbiter Maneuvering System. It's 2 segments on the back, either side of the vertical, and it has the thrusters that maneuver the orbiter when it's in space. There's another 16 thrusters up front. It also has the 2 orbiter maneuvering engines their most important feature is they slow you down when it's time to come home.
Well, Terry, here we're seeing Columbia brought in 1979. I think is probably when that picture
Correct.
would be.
Easter weekend.
The Nixon administration approved the shuttle, and Congress approved $5.5 billion in April of 1972 to build this orbiter. And of course, we didn't launch it till April 12th, 1981, a 9-year development period there. Largely because of,
well, there was multiple things with that had issues with it, but it was a new design. This was designed by a bunch of guys with slide rules and pencils, and and it was a whole new concept. So the largest vehicle ever launched into space,
100 tons.
Yes. So it took a while to figure out all of the issues with it. And the other thing is, we put it through more than 2 years of testing as we were building it to make sure all the systems would function correctly.
Marty, we've got another question.
2 questions. First question from Stan Anderson. What's the weight of the tile in your hand? And you may want to mention there's different size tiles, Terry.
Yes, I will. Well, there are different types of tile on the vehicle. The one on the left is the most common. It weighs 9 pounds per cubic foot of material. So the tiles are actually 94% air. But it is an excellent insulation because it can withstand up to 2,300 degrees on the outside and not let the aluminum or composite skin underneath exceed 350 degrees. This one happens to be the thinnest tile off of the ship. It's only 1/4 of an inch thick. And like I said, with Columbia's initial flight, there was over 32,000. Vehicles like Atlantis and Endeavour have a little over 24,000 tile on them.
As far as they weigh, I've got a Snickers Halloween candy bar over there on my desk that weighs more than this tile, or 2 of these tiles put together. I'd say this is about 2 ounces.
Yeah, and this is actually heavier material. This is 22 pounds per cubic
and
foot.
This one is space flown, huh?
On Endeavour.
Well, I thank you for that, Terry. That's a nice little gift. For, and you see a bunch of numbers on them, and tell us about. You even told me the bag of sand that this came out of.
That's right. We traced it all the way back to the original bag of sand. It is the main ingredient is silica. So, but by the part number, it tells us where it goes on the ship, and then the serial number. And like I said, traces all the way back. If we've done any repair work on there, we put that document that authorized the repair. We put that right on the tile so we can look at it and trace it right back to whatever we did with it. And they are extremely fragile. They are more fragile than an eggshell. It doesn't take much at all to chip them.
Mm-hmm. Quite a process in there, and we'll talk more about that on our shuttle shows and get some process people in here. And I'd like to mention we've got Connie McDaniel helping Marty today. Hi, Connie. Thank you for your help today. She's learning our Streamlabs there to help out here. So she's a great volunteer here. I want to give a shout out to Connie McDaniel. Right. Another question, Marty?
Yes. Hi, Uncle Terry. It's Amanda and Logan, Jackson, and Mason. And you already answered their question. They want to know what temperature can the tile withstand.
Correct. Thanks, Amanda.
All right.
Hi, guys.
Great to see you guys. We love your uncle here at our museum, and his knowledge is unbelievable, but we just love attracting good people like you here, Terry, and means a lot. Here's the aft end, and Marty, this is what Marty Winkle, our co-producer here, worked on as a manager of the launch process systems, and they call those the SSME, Space Shuttle Main Engines. Wow, what a fancy name, but they're also called the RS-25s, the Rockwell built. Tell us about them, Terry, and they actually take them out and service them, right?
Correct. You have 3 main engines back there, and they're designed to be removed. The original concept was they would fly them multiple flights before taking them out, but we took them out after every flight. Sometimes if we found an issue with an engine on another orbiter, we would take out the engines we had just put in and send them back to the engine shop and have them inspect them as well. So I know of flights where we took the engines out 5 different times and that. But we have to take over 200 panels off of the aft portion of the orbiter, and then we have a special heister once we disconnect all the plumbing associated with the engines, and it comes over and takes one engine out at a time, takes it to the engine shop. When we get our other work done in the aft compartment and we're ready to put engines back in, then that same heister would bring engines back one at a time, and we generally get 3 engines installed in one day.
Interesting. And 5 of those engines, it could be a couple of these, are on the Artemis SLS rocket as we
Correct.
speak.
Instead of going and designing a whole new engine, why not use an engine that had a good success rate? And so
they're going to toss them in the ocean, sadly, but
correct.
There's a lot of pride, I know, with the engine people, wasn't there?
Yes, it was.
To refurbish these, and in the early days of the shuttle, you'd have probably wagered that there'd be a catastrophe because one of these engines was going to blow up or have a problem.
Yeah,
and
it did not. We had problems.
There's only one out of 135 flights that actually failed.
Yeah.
Take 135 times 3 in engines, and that is a low percentage of failure.
There were times we got down to almost the end of the count, less than 4 seconds, and the computer detected something wrong with one of the engines, and they shut it down before they lit the solid rockets.
Because those started ahead of time.
Yes, yeah, they start like 6 or 8 seconds ahead of the
6.6. I learned from
6.6.
Mr. Winkle over
Okay.
there. Yeah.
Yes.
Right.
6.3.
6.3. Okay.
And as long as I got your attention, let me point out the OMS RCS engines,
Okay.
since we mentioned that before.
Yes.
Yes. You can see them up there. They have the red covers on them. So
Those are the cheeks that come off the end there. That's the fuel tank for those. Is why that sticks out like
correct,
that, right?
correct. And that's where some of the worst hazards are. They have the hypergolic fuels.
Which are fuels that have no igniter. When the two liquids hit each other, they ignite.
Correct.
And there's some nasty stuff too.
Yeah.
I've learned. All right. Here is Columbia taking out to the pad for the second time. Probably the beginning of October 1981. I don't know if you remember the rollout date, but it was launched November 12th. All right. I'm sure you were there watching this. What were the emotions? What were the thoughts of this? By the way, explain the one of 2 white tanks there, ET tanks.
Correct. The external tank in the early days was painted white for the first 2 flights. After that, to save weight, they no longer desired to paint the tanks. But what
were your emotions there when you're seeing this go out there?
Oh, it's really great to see that much hardware, something that weighs that much, and it's all assembled now because it was basically 3 different components being assembled: the orbiter, the solid rocket boosters, and the tank. And now they're all put together and mated in the vehicle assembly building. Then the crawler picks up the whole mobile launch platform with the space shuttle on top of it and takes it for its journey out on the gravel road out to the launch pad, takes it up to the pad, sets the mobile launch platform down, and then the crawler backs out from underneath it, and then they start processing it for launch at the pad.
It's so interesting. It's something that has to go 17,500 miles an hour to do its job in Earth orbit. Starts out just crawling.
Yeah,
and ends crawling back into the garage.
Yeah, a half a mile an hour on its way out to the launch pad.
Yeah. Here's the beautiful launch of it that had Joe Engel as the commander, Richard Truly as the pilot. Of course, they followed the great John Young and Bob Crippen as the first 2 of this. But I'm just going to say this has to be just as scary as the first. You're using a reusable 100-ton spaceship that just spent 2 days in space in April, and now 130 days later, approximately, you're 150 days, I think, total.
But you got some confidence. It worked the first time.
Okay.
Okay, so you got that. It's not brand new like it was for Crippen and Young. So you got the fact that it did fly once. Now we're going to fly it again.
You see that little black triangle there against the white ET tank? That's how you know it's Columbia, because the other ones didn't have that black on the wing.
And there it is, almost clearing the top of the pad. You can see the lightning tower to the left.
KSC be done with it in another second, and it goes over to Johnson Space Center on there. The white was to be seen better, I think, optically, but honestly, the orange shows up a lot better.
Yeah, and weight was a whole issue because, it took a lot of fuel to lift all of that weight. So anytime you could cut down the weight and by, not painting it saved a lot. So we used to do modifications on the orbiter where techs would work for 30 days on one project to lighten the orbiter by 4 pounds. But that 4 pounds could be used for payload and that. So we made it as light as possible as long as we kept it safe.
Or more 4 pounds of shrimp cocktail to take to space to eat, maybe. Well, we're going to have Terry give us a quick little look inside the OPF a little bit, some of the structures there. It's quite a complex facility inside, more than meets the eye. We have a replica of it here in our shuttle gallery that people walk by because they really don't understand what it is, with all these levels of floors and gantries and stuff in there, Terry.
And when people would come in, once we got the orbiter in, it's coming in nose first, and this happens to be a photograph of it going out when it's going to get ready for flight. But when we would bring it in, it comes in nose first, then we disconnect the tug and then lift it up. Now in the early days, we jacked this 200,000 pound orbiter up by hand. And then eventually we did modifications.
Which is hand jacks?
Yes, special hand jacks. But yes, the techs sit there and pump the jack and lift this orbiter by hand. And then we did modifications and cut into the thick concrete floor and actually put in hydraulic lifts to go ahead and raise the orbiter.
We're going to look underneath the belly here, just sort of like eat your heart out, everybody. This is your workshop here. Underneath the gears there, and every tile's got a number on it right up there.
Yes, yep, and it's depending on where they're at on the orbiter as to how close the spacing has to be in between them, and each tile can physically move. This vehicle goes through a lot of stresses. It expands, contracts, flexes, just like an airplane. If you look out on the wing of an airplane when you're flying and see how much flexing is going out there. Well, this structure underneath that, but the tile are rigid and they don't flex, so they have a special pad glued to the bottom of the tile and then glued to the skin of the ship. But if I could reach up there and touch it, you could actually move each one of those tiles.
And when Columbia's first flight, they saw some tiles missing, particularly on these OM pods, orbital maneuvering system pods there, and that kind of caused some concern.
Especially since that's the only area they could see. They couldn't see the rest of the vehicle from what the astronauts could look out windows 9 and 10. But so they were concerned, but like I said earlier, that's relatively low temperature area, and the tiles are designed to absorb heat. Even if a portion of one of them is missing, the remaining portion will absorb heat around it. So it came back with no over temp of the structure or even the paint.
And of course, we had the landing picture in there earlier there. So there's a good view of the doors deployed on the landing gear.
Yep. And you can see the elevons above it right there. But this is looking underneath the left-hand wing as you're looking toward the forward section of the orbiter.
I heard a good John Young story. Forget who shared it, but one of John Young's questions to the shuttle people was, how can you guarantee me that some computer glitch isn't going to pop open one of those wheel wells while we're orbiting Earth? And so they put a rerouting circuit in there with a cover on it. So do you remember anything about that?
Yeah, this switches had switch covers that went over them so you couldn't inadvertently do that. But that was one of the concerns. So
because to save weight, you didn't have a retractable motor on them, right?
Well, you did hydraulically to retract them, but there was so much pressure around caused by the seals around the nose landing gear door that we actually had to use 4 people to help close the nose landing gear door. The mains would close, but they did.
And what high-tech instrument did they use to close those doors?
Well, the first time we did it, we took the janitor's floor brooms, the big wide dusting brooms, and we wrapped them with what we called elephant hide, but it's a special padding in that, and actually used those to close the doors. And then engineering designed some special brooms, and they still called them. They would make an announcement, time for the broom crew, and 4 people would go inside the clear and actually push the doors closed.
I've seen a picture of that. We'll get one and share that with everybody again. Again, we're enjoying stories with Terry White, who I call a national treasure, along with our co-producer here, Marty Winkle, all these people that worked on the shuttle did. Interest in jobs so specialized they didn't translate to anywhere in society. But the result is 22 years of the space station being continuously occupied, doing great things for humanity. Here's a kind of tight quarters, Terry. This picture shows.
Oh yeah, to make it accessible for us to work, like I mentioned earlier, we closed all the gaps up as tight as we could around them. We didn't want to have to wear fall protection when working at heights because the fall protection equipment could damage the orbiter and that. And so, yeah, once we got it in place and lowered all the platforms or extended the platforms and that, there was very little space around it. And when people would come into the hangar for their first time ever in there, they would walk in, they'd walk around underneath the orbiter and said, "I thought you had a spacecraft in here." I said, "We do. It's right above your head." They could not believe that they were standing underneath a vehicle because you can't step back and see it.
Yeah, it's interesting. It's very, very, I've heard that a lot there. Well, there's the aft end to show how those engines were taken out and actually the stabilizing.
Yeah, the body flap, we had to remove the body flap off of Challenger. And so this is one of the
We're going to do
shots
another
of doing-
program with Terry on the engines. He sent me a lot of cool pictures of looking in those areas there and to talk about the actuators and the fuel lines and all that stuff is quite fascinating. Were there any smells in this place? Plus, it's pretty noisy in there, is it not? Because of fans going on all the time.
Actually, the noise level in the early days, we had the hydraulic pumpers were inside. So that was like standing out on a runway. I mean, it was extremely noisy. And in testing Columbia before its first flight, we ran hydraulics around the clock for 30 days without ever shutting anything down, testing stuff. We wore out the actuators for the elevons, exceeded their mission life before the first flight, and we had to put new actuators in.
So you had confidence that they would stand a long
Yep,
mission.
yeah, we tested everything over and over again.
As we look at the beautiful engines there, just wishing I could stand there and see that. Any smells?
Oh yes, yeah. You had residual smells from all different kinds of things. You had noises from repairing the tiles. We actually used high-speed dental drills with diamond bits to repair the tiles. So people who didn't have good feelings about being at the dentist, when those drills would crank up, you'd see some people cringing because listening to the drills. But yeah, there was different commodities we used, and you could tell right away if you were exceeding the limits, especially things like the ammonia service and that got your nose right away. So we had emergency clears just simply because of we exceeded the threshold of some of the components.
It's just fascinating that it goes from this, and then they put it all back together again. And check it out, all the electronics. Marty, what's that like with you SSME guys there, taking these engines apart and putting them back in? Were you ever involved in the testing of the computer systems on that, or what?
Well, I never got involved with the removal or testing of the engine in the engine shop.
Mm-hmm.
Or I had more work with the testing of the engines while they're installed on the vehicle. It's a subsystem test.
Thank you.
As well as launch support.
And again, just to show you some cool pictures that Terry's got of the whole facility in there. You go to work and you walk in there and you go, oh, let's see, what are we going to do on the space shuttle today, huh?
Yep.
But we're going to show you one day. There is a hellacious timeline it's like a bar graph sideways of your flow. They call that the flow chart. The flow.
Correct. Yeah, the flow chart. Yep.
Okay.
Yep.
And we're going to go over that one day with y'all out there. Question?
Okay, I'm going to read it the way he wrote it, and it comes from AC. He said the white paint was no longer used to decrease the weight. Were the shuttles built after Columbia made lighter with the materials they were constructed of?
Yes, they were. Columbia being the first was the heaviest. Okay, Challenger was next. It was a little bit lighter. It wasn't originally designed to fly into space, but it did. And then Discovery was after that. It was lighter. Atlantis was next. It was the lightest because Endeavour was built in the 90s, and it was a little bit heavier than Atlantis because of some of the changes we did modification-wise. But each one of them got lighter and lighter till the very last one, but none of them came close to what Columbia weighed.
And tell us about the unique. Go ahead, Mark.
It had nothing to do with the white paint coming, well, not painting the external tank. That was just a 600-pound savings of weight that they used for payload.
Yes.
It had nothing to do with the lightness or reducing weight of the
Orbiters. No, but everything we did orbiter-wise. And in the early days, they used to tell us it cost about $10,000 a pound to lift the payload into orbit. So anytime we could save weight, we were saving money.
And Columbia was also unique with the telemetry it had on it. As we're looking at the typical government picture of one man working and 6 people watching.
Now, some of them are paid watchers because you have technicians doing the work, and you have quality control people that are monitoring what they're doing, and then certain tasks you have a NASA quality control that's watching them work, and then you also have the engineer who's and that's his system or her system, so they also want to come out and watch the tasks. The best engineers come to the floor and support, and that way if you have a question as you're doing something, because sometimes it doesn't exactly work the way the paper's written, so having the engineer there and say, well, this is what I intended, so.
I wanted to throw this picture you sent me there. That's a Miami Chuck. Say who that is? Miami Chuck, I think he wrote down there. One of your workers.
Yeah, and I don't recall exactly which Chuck that was because there are several Chucks in it.
Well, thought it'd be interesting that he had a couple pictures of the leading edge of the shuttle there. That, of course, was created the disaster of Columbia when a hole got punched in it. And comment a little about what we're looking at there, Terry.
Okay, we're looking at the leading edge of the wing and the reinforced carbon panels. These panels, which is the gray material right here, have been removed. Some of them have. You can see some of the forward ones there. And we're having a lot of corrosion issues there. So we're in there putting adhesive on there to minimize corrosion once we got everything cleaned up.
Now, corrosion from where?
Well, remember, this vehicle sits out at the launch pad right next to the Atlantic Ocean. So there's a lot of corrosion on the structure. The orbiter is exposed to a lot of corrosion as well, so we're constantly looking at different things, and we even experience dissimilar metal corrosion where we have things contacting aluminum and it causes corrosion just because you have two different metals together.
Very interesting. Well, we hope you're enjoying this Stay Curious episode with Terry White, and we know Doug Forrest is in Los Angeles, and Tom Usiak, hi to you in Lancaster, Pennsylvania. I was thinking about them up in Pennsylvania because our low today is going to be 71 tonight.
Okay.
And rubbing it in there to our, Tom and Mark Usiak. Melissa Pope is watching at the Space Coast Office of Tourism. And hello to Margot Watson. Young lady, thank you for watching. Why don't you give a few shout-outs there? Now?
Okay, to Hazel Banks.
Hey, Hayes.
And Steve Hammer. And say hi to my daughter, Rebecca Vicknair, and the 3 grandkids that I'm sure are watching with her.
Right.
Okay. And
they live in the New Orleans area, is that right?
Where you go north of Baton Rouge.
Baton Rouge.
Yep. And
you didn't bring me a gumbo back the last time.
No, I did not.
You ate it all right. I love that gumbo.
You hear that, Rebecca? I got to bring home gumbo.
Humberto
Lopez. Brian Anderson.
Thank you for watching, Brian.
Yeah. Steve Strange.
Dave Stang.
Dave Stang.
Yeah.
That name sounds familiar, but Keith.
He's one of our ace diamond watchers here.
Okay. Keith Sowell.
Yep, I Keith.
AC. And of course, we already mentioned Travis White up in Washington State right now. Angela Butler.
Alyssa Series at the Office of Tourism. Thank you, Alyssa.
Yep. And Carlton Bailey.
Yeah, launch photographer Carlton.
Okay.
Who was so frustrated, like everybody in Titusville, they couldn't even see the flame of the Falcon Heavy through the fog here.
Yeah, well, my brother said he could see it clear from Cocoa.
Well, Cocoa, I saw it from I was on Merritt Island.
Yeah.
Yesterday morning, but yeah, that was quite an anomaly. There, they never launched a shuttle in fog like that, did they?
No.
Marty or
we had a lot more weather restrictions than expendable rockets have.
Well, we're going to show a couple other pretty pictures here. Here's one of them right there. Let me back up there. I love this picture there. As a photographer, that's got an artistic, a lot of lines going on there. That's a Mark Usiak photo there, Mark Buddy, or Carlton Bailey would see that in their eye there. The nice juxtaposition of the wing and the rudder and OM pod and the tail there. But to give you those of you that have not had the privilege to stand beside a shuttle, and I certainly have had a privilege to see, of course, Atlantis here and Discovery at the Udvar-Hazy. They're big. I think your first impression is, my God, it's that big.
Yes. Yeah, I got to do a shout out to Pat White, my wife. She was in the studio last time, but
hi, Pat. Thank you for letting him out today and taking good care of him.
From home. And you know, it's odd, but the orbiter's length is the same length as the Wright brothers' first powered airplane flight.
No way. Oh, yeah. the distance it traveled.
Yeah, the distance it traveled. So could you imagine telling the Wright brothers when they landed after their first flight, says, well, in less than 100 years, we're going to build a spaceship.
Well, the orbital vehicle is 122 feet long.
And I think their first flight was 124 feet.
Its wings are 78 feet wide. Its wheelbase is 78 feet. That couldn't be right. The wings from tip to tip.
Is 78
the cabin is 23 feet above the ground. That's a 2-story building, almost a 3-story building there. And, of course, it weighs 4 million pounds at liftoff. The entire shuttle stack from the base to the tip of the ET is only 184 feet. That's about 40 feet shorter than a Falcon 9 rocket there. But surely impresses you when you look back in history and you see the pictures of it 9 miles away from Titusville and so forth on there. Terry, what an awesome knowledge that you laid on us today. So interesting to see your perspective of the space shuttle. Sum up again what a big deal this was, that America was using a reusable spaceship. Of course, those of you that don't know, the Mercury, the Gemini, the 1-man Mercury, the 2-man Gemini, 3-man Apollo were all one-and-done spacecraft.
Correct.
They didn't even want to try to rebuild any of those systems. And as tiny as those spacecraft were, I think you could get 3 command modules in the shuttle cargo bay and about 5 Mercuries.
Yeah, it's 60 feet long, so yeah, just the cargo bay.
Yeah, in there. So tell us out there, just, this is 1981. We're talking 41 years ago. You're standing out there with all your working friends, the VIPs and everybody watching this liftoff.
Well, we stayed away from the VIPs because we watched it from over where we work,
right, right,
north of the vehicle assembly building. But yeah, it was. They were just proud of everything they'd done, and they wanted to see it go back to space and get back to where we could start working on it again for the next flight.
And it was a 2-day mission. They came down a little early because one of the power units.
They had a problem with the fuel cells. Yeah, there was supposed to be a 5-day mission, so they cut it short. They were only up 54 hours.
It took up Art Edwards of Canada Arm. Hi, Art, a good friend of our museum. That was one of the managers of that Canada Arm. Great partner Canada's always been with remote arms and other things.
Yeah. So yeah, that was the first time we flew. The arm was on STS-2.
Great. Well, good. Terry, thank you very much. We got the Lori White Taylor's watching also.
My sister.
All right. Good. All right. Well, thank you, Lori, for watching your big brother or little brother?
I'm her big brother.
You're her big brother. Okay. All right, buddy. Well, hey, thank you, Terry.
Yes, sir.
We appreciate you. Glad that you're back to your health there. And we know that you all enjoyed this episode of Stay Curious, and we can't wait to have Terry back. So, Marty, anything we need to clean up over there?
Nope.
Thank you, Connie, for helping assist Marty there. We hope to have her in the driver's seat there a time or two and give Marty a break. Terry Marty's been a faithful volunteer for Stay Curious here for 2.5 years, and
Good.
you can't give him anything because he's got everything. But we love him, and it's just a great service that all of our volunteers do here. So, well, thank you all. We'll be back tomorrow with shuttles of the month of November. We've got 16 shuttles that launched in the month of November. You were pretty busy
Yes.
around Thanksgiving time. So we can't wait to have you back. And I'm Mark Marquette on behalf of Terry White, Marty Winkle, Connie McDaniel helping us here, and our wonderful director, Karan Conklin. We can't wait to see you again to bridge the space between us.